If there were sound in space, our galaxy would roar like a Formula One race car. After all, the Milky Way races at a speed of 631 kilometers per second. But while a race car speeds up thanks to engine power, our galaxy gets dragged by some supermassive object. We know that the Great Attractor pulls our and the neighboring galaxies closer at a speed of 330 kilometers per second. But wait a minute, I just said that we're moving faster than that, didn't I? So, is there another mega object besides the attractor that's longing to swallow us up? Or are we getting sucked into another universe? So, what is sucking our galaxy up at this incredible speed? What is the origin of the Great Attractor? The universe started with the Big Bang. Since that point, it's been constantly expanding. However, scientists have discovered a paradox. Despite space expansion, galaxies can still approach each other. It's the result of gravitational force. This is how things work for us. The Milky Way, the Andromeda, and the Triangle Galaxy form the local group. Along with other groups, our galaxy is a member of the Virgo supercluster, which in turn belongs to the Laniakea supercluster. This supercluster's diameter is approximately 500 million light-years, and it contains 100,000 galaxies inside of it. The Great Attractor is lurking in the center of the Laniakea. It's the one that's been forcing us to hurtle at a velocity of 330 kilometers per second. The attractor hides from scientists behind the disk of the Milky Way, but there's enough data for us to become aware of it. The attractor has swallowed thousands of galaxies and gained 1,000 times the mass of the Milky Way. The enormous concentration of objects turned it into a gigantic vacuum cleaner. If it has an opportunity, it'll drag you in a matter of seconds. But despite the facts, the attractor isn't at the top of the space food chain. What object can have the Great Attractor and us for dinner? Almost 100 years ago, Harlow Shapley, the then head of Harvard Observatory, and his colleagues studied the southern celestial hemisphere. They observed a cloud of galaxies in the Centaurus constellation. Those were the first steps toward discovering the Shapley supercluster, the largest concentration of galaxies in the nearby universe. It lies far beyond the Great Attractor, 650 million light-years away. The supercluster includes 8,000 galaxies and is 10,000 times the mass of the Milky Way. There's also an area of galactic concentration at its center, and it's the gravitational heart of the Shapley supercluster. And while the Great Attractor is accelerating us to 330 kilometers per second, the Shapley supercluster is adding 251 kilometers per second. But that's, again, not the complete formula of our speed. It's time to discover the missing Predator X. In 2016, scientist Renee Kron-Korteweg and her team examined X-ray images of the Shapley supercluster. They were the first to notice another giant, the Vela supercluster. Its center is located in the southern hemisphere constellation of the same name. It's 870 million light-years away from us. Despite the colossal remoteness, this cluster has enough force to attract us, and these are the missing 50 kilometers per second. Just imagine what will happen if these three superclusters eventually turn into supermassive black holes. Not only will we find ourselves in one of them, but there will be no one left to create a cool video about this black space triad. But what if our final destination is much more unpredictable? What other extraordinary forces can attract galaxies, including ours? The major problem is that our science can't yet fully explain how gravity works on enormously large scales. It's simply impossible to discover the origin of many gravitational forces. For instance, the objects within the Milky Way compose only 5% of the galaxy's mass. The other 95% of the weight remains in the dark matter halo, invisible for direct observation. It's the area that encompasses the galactic disk. It turns out that the Great Attractor, the Shapley, and the Vela superclusters aren't just the galaxies, but also have their much more massive dark halos. The ways they affect global gravity forces remain to be discovered. However, there's another, even more mysterious dark force. Astronomers found an entire flow of galaxy superclusters in 2008. It moved in a line from the solar system to the Centaurus constellation. The phenomenon was called the dark flow. Its speed reaches thousands of kilometers per second, almost twice as fast as the Milky Way, and its length is approximately 3 billion light-years. It can be compared to an ocean current, and although in the past scientists did manage to identify the source that attracted the objects, everything looks absolutely mysterious this time. The dark flow pulls galaxies towards an area that lies beyond the limits of the observable universe. If galaxy clusters were fish in an aquarium, the dark flow would trap them on the surface of the water and force them to jump out. Scientists suggested that the origin of the flow may hide in another universe. Perhaps it has approached us closely, and now it may be leisurely absorbing us as if drinking mojito through a straw. Unfortunately, we don't have an opportunity to observe the Milky Way from the outside and evaluate how it may be affected. We can only go with the flow and cross our fingers, hoping our galaxy won't be washed up on some foreign and dangerous shore. But what would happen to us if we ended up in another universe? A cosmologist and theoretical physicist, Laura Mersini-Houghton, has been working on a theory of the multiverse. She believes that anomalies observed in space emerge due to the attractive forces of other worlds. It sounds like a sci-fi movie plot, except that Laura's hypotheses are confirmed by astrophysicist data. In the 80s, physicists Stephen Hawking and James Hartle developed a theory of the emergence of the universe. The scientists claim that the Big Bang created not one, but countless universes. Some of them may be our universe's twins. They may contain similar Earths and our identical copies. Others might differ sharply while still offering acceptable living conditions for surviving. But the third type of universes we should definitely avoid. They may work in terms of unalike laws of physics, or there may be no laws at all. And we have as many choices of surviving in them as we usually do during Black Friday in a superstore. If we actually are getting sucked into another universe, the silver lining would be meeting someone from Marvel's Avengers on the other side. It sounds better than boiling oceans, acid rains, and planetary rings that can rip apart the surface of our planet. The velocity of 631 kilometers per second at which the Milky Way is moving right now is pretty damn fast. If you had rocketed off Earth at this speed at the beginning of this video, you'd already be preparing for a landing on the moon. However, our galaxy is still millions of years away from meeting the nearest supercluster or another universe. So, for now, we can relax and feel like the greatest racers in the galaxy without making it off our couches.